Well, Del, welcome to my office.
Hey, I love it.
I have the coolest job in the world, I think. I get to share my passion of the sky with people and our Creator. I get to do both of those together. This is a cool thing I do.
Oh my goodness, now you're gonna make me buy a telescope.
Okay, threading through part of the summer triangle, we have this faint band of light that goes up across the sky all the way over here and back behind us over this way. It's a faint band of light. We call that the Milky Way.
Yeah.
And over here near the southwestern horizon, it gets thicker. Notice it's thicker over here and it's over there. We're kind of losing it. That's the late summer Milky Way. Yeah. The Milky Way is our galaxy. It contains a couple 100 billion stars. It's round and it's flat. It's got a bulge in the middle. Kind of reminds me of an over-easy egg with that bulge in the center. We're about halfway out from the center, about 25,000 light years. So when we look towards this part and it gets thicker, we're seeing that bulge near the center of the galaxy. When we look over here, we're looking 180 degrees away. We're looking directly away from the center of the galaxy, so it's not quite as bright. This is the summer and autumn Milky Way. This is the beginning of the winter Milky Way showing up over here. You know, for us in the northern hemisphere, the Milky Way never gets, at least the center, doesn't get very high in the sky. Sagittarius, you can see early in the evening here yet. It's prominent in the summertime, and that's where the center of the galaxy is, and it's never very high in temperate latitudes in the northern hemisphere.
Well, to me, the Milky Way has always been the most fascinating thing. There's something about it that just almost stirs you when you see it.
Well, you know, most people never see it the way God intended it because of can't get away from the city lights where it's dark like this. But I found when people get to a dark site like this and they let their eyes get a little bit dark adapted, they're stunned. I've had people gasp when they see the Milky Way for the first time.
Well, Danny, do you think, is that the reason God made it, which is amazing to be in awe? Do you think that's why God made all of this?
I think a good part of it. You know, we have some purposes given for the stars in Genesis 1:14-19. It's a day 4 creation account. It mentions the stars and other heavenly bodies to mark time, to rule over the night, to be for signs, for marking of time passage, seasons, festivals, and so forth. But Psalm 19 also tells us the heavens declare the glory of God, and the firmament showeth his handiwork. And it's like a billboard that I think is advertising that God exists, he's powerful. You know, Psalm 8, Psalm of David, and he says, you know, when I consider the wonder of your hands, the sun, the moon, the stars that you've made, you know, what is man that you're mindful of him, son of man, that you regard him. You know, he was a shepherd, and he spent a lot of nights, I'm sure, watching the flock. He's probably doing it from 2,000, 3,000 feet elevation in a Mediterranean climate, a lot like we have out here. And all he had was 2 eyeballs that he was using. And that really brought him close to his Creator. And that's one of the neat things about astronomy. I think one of the things that always have impressed me is the fact that I see the handiwork of God in this.
Well, Danny, beyond the beauty of what we see here, do you see purpose for what God has done as well?
Well, yeah, I think the size of the universe, it demonstrates his mighty power. You know, Romans 1 tells us that the world around us speaks of the fact that there's a Creator, and he's very powerful. That's all it tells us, by the way. Can't get specific information about our Creator, but it does tell you there is a Creator. And that's one of the big messages. But, you know, there are other purposes, like timekeeping. And there's a bright star. We'll stay up late enough tonight. We'll see it. Sirius. It's the brightest star in our sky. It's called the Dog Star. In ancient Egypt, they saw it rising before the sun did. You go behind the sun in spring, late spring, and then emerge in early summer, midsummer, and behind the sun's glare. And they first spot it in the morning. And that coincided within a week of the Nile River flooding. And when it did, it flooded its banks, and they could tell when they had to prepare for planting the crops because that would re-nourish the soil, and they had to be ready for that. And this became known as Dog Days. It goes back to ancient Egypt, and it comes from the Dog Star. So people have been using the stars for marking passage of time, and you may have heard of astrology and the zodiac, and these are 12 constellations along the apparent path the sun follows and the moon follows and so forth. They've perverted that into fortune-telling sort of thing,
Yeah.
but actually those things have a useful purpose for reckoning time on small and long scales. The month is determined by originally at least, by the phases of the moon. You know, the Hebrews still keep, the Jews still keep a lunar calendar. We have a lunar solar calendar. We have a solar calendar, so we've have over 2,000 years ago, abandoned the days of the month staying in sync with this moon's phases. But on the 15th day of the month on a lunar calendar, it's always a full moon. And, you know, the big feast like the Passover falls on a full moon because of that reason. It bounces around on our calendar, but it's always on the 15th day of that one month, the first month of their year, on a lunar solar calendar.
So were all those festivals tied in again to?
They were tied to these things. Apparently, the first Passover in Egypt happened at a full moon. It's interesting that if you read it very carefully, in Exodus, it says that Pharaoh had enough when his firstborn died.
Yes.
He called Moses at night and said, "Leave now." Forget what you saw in the movie The Ten Commandments. They didn't leave in the middle of the day. They left at night. Now, you're a pilot. You've been out at night. How well can you see when the moon's full?
When it's full, you can see a lot.
Very well. So if you don't have trees overhead like we have here in the desert and they have in the Middle East, they actually started their trip at night with a full moon.
Under a full moon.
And so in order to commemorate that, for past 34 centuries after that, they always commemorate it on the anniversary of that, which is the full moon after the first month of Aviv in the spring. And so it really is on the anniversary on a lunar calendar.
Well, Danny, what you're explaining to me is that it's not just a beautiful sky, but it's a very ordered sky. There's a lot of order that's going on here.
The patterns repeat every night. They repeat every year. They come back in their season. There's a lot of regularity going on here. It's truly remarkable.
We have been talking earlier about the concept of irreducible complexity when it comes to biological systems. Would it be fair to apply that same kind of a term to what we're seeing here?
Well, it's a really tricky thing because living systems are a bit different from what we have here. I've been wrestling with this idea of design in astronomy for a long time. I think some creationists, some biblical people maybe see design where there isn't any sometimes, but I do see design here. I find it incomprehensible to me that this is all just an accident. Like the moon, the more I study it, the more I'm impressed with what we see there.
What do you see when you look at the moon?
The moon's different. we have like 170 satellites, or natural satellites orbiting planets. Jupiter and Saturn have scores of satellites orbiting them. We only have one. Most of the satellites are small, but Jupiter has 4 large ones, Saturn has 5 or 6 fairly good-sized ones, and the Earth has a good-sized one too, even though there's several larger than it is. But the moon's orbit is different. It's a little tricky. I'll try to explain this best I can here. The sun is 400 times larger than the moon. So if you had a ball the size of an inch across, that would be the moon, and the sun would be 400 inches across.
Wow.
Gives you a bit of scale.
That's not what we see, though.
No, because you see the sun is not only 400 times larger than the moon, but it's also 400 times farther away. So if you take something and move it as far away as it is larger than the other, they have the same size to us. Both the sun and the moon appear to be about a ½ degree across in our sky. Now, on rare occasions, the moon passes between us and the sun. Doesn't happen very often, about every year and a half somewhere in the world, usually in Timbuktu. And when that happens, the moon just barely covers the sun up. If the moon were a little smaller or a little farther away, it wouldn't do it at all. If it were larger or closer to us, it would be grossly over total. Wouldn't be nearly as spectacular. We get these rare and very spectacular eclipses.
Do you think that's a design that God gave to us?
It's if you look at the other satellites, 170 or so in the solar system, none of them have those kind of requirements. Either they don't happen at all, or they're grossly over total, so they're not very rare and they're not very spectacular. It takes. I read once that on a given place on the Earth, we get a total solar eclipse about once every 400 years. So either if you see one, you're either very lucky or you plan to be there to see the thing. And so these eclipses are spectacular and rare, and this is the only planet on which it matters, and it's the only planet on which it happens. I don't find that to be just a coincidence. I think there's more to it than that. But there's another more important thing about it. The moon's orbit is different. We have the plane of the Earth's orbit around the sun. We call this the ecliptic. Imagine a flat plane here. The sun's here, and every year the Earth goes around like this, and it causes the sun to seem to move through the stars. That defines this ecliptic across the sky, this big line across the sky, the plane of our orbit. Now, the moon's orbit is very close to that plane. It's tilted a few degrees, but basically the moon orbits around the Earth in the same plane that the Earth orbits around the sun. Of the 170 or so satellites in the solar system, it's the only one that does that.
Is that right?
All the others have different orbits. The most common type of orbit is above the equator of what we call the equatorial plane of the planet. And each of the planets have different tilts. Our own Earth's tilt's about 23.5 degrees. So if this is a plane of the Earth's orbit, there's another plane, the equatorial plane, that's tilted 23.5 degrees to that. And if the moon were like other satellites in the solar system, it would be orbiting in this plane, not in that plane. But the interesting thing is, that tells me something right away, that the origin of the moon must be different from other satellites. It must be unique, which we kind of know that from Genesis because the purpose is involved. I believe the moon is unique, and the origin scenario perhaps would be unique as well. And, you know, astronomers have tried to claim, well, we need to study the satellites of the other planets, hopefully to learn more where the moon came from. Well, I say nonsense, because the moon's orbit is unique in the solar system. But there's something else about the moon. If you compare the ratio between the mass of the moon and the mass of the Earth, it's pretty high. Earth has about 81 times more mass than the moon does. But when you look at other planets, they have thousands or tens of thousands of times more mass than their satellites have. So when you look at the ratio between the mass of the planet and the mass of the satellite, it's closest for the Earth by quite a bit, Earth-Moon, than it is for any other in the solar system. Now, this is tricky. The Earth, you know, has a tilt of 23.5 degrees. That causes our seasons. But perturbing effects, the other things in the solar system are yanking on that tilt, and over time it would cause that tilt to change tremendously. It would go from being 23.5 degrees to being 0, to being 90, back to 0, waffle all over the place. It would slowly happen, but it would happen and waffle everywhere. What that would mean is that eventually there would be no seasons, and eventually most of the Earth's surface would be simultaneously in the tropics and in the Arctic regions. Could you imagine the devastating effect it would have on living creatures?
Sure.
That's if there's nothing else going on. The planets and the sun and everything else out there would do that to the Earth's tilt.
So why doesn't it?
Because of a very complex interaction of the moon, it stabilizes it and keeps the tilt within about a 2-degree range. It can't leave more than about 2 degrees, which we can withstand that small change. And it only happens if two things are true. If the mass ratio is high, which is unique to the Earth-Moon system, and this is critical, that the moon orbits in the ecliptic plane, not the equatorial plane. And it's the only satellite in the solar system for which that's the case. Now, again, you could argue that's a coincidence, you know, but how many coincidences are you allowed before you begin to realize, well, maybe these coincidences aren't coincidences at all? But, you know, my job as an astronomer and as a creationist is to try to identify these interesting little features. And those are two that just are screaming design to me. I have to keep saying, well, there is design here. I think it's not not happenstance. You know, if this was all a result of some cosmic accident, would you expect that many coincidences to take place? Now, you can talk about the Earth itself, the unique properties it has, its proper distance from the sun, the right kind of mass, the right kind of atmosphere. The atmosphere of the Earth is very curious. It's nitrogen-based. It's what we call diatomic. We have most of the gas in our atmosphere has 2 atoms per molecule. And that's really significant for life, too. In fact, so much so now that people looking for life on planets around orbiting around other stars, they think the important thing to look for is a nitrogen-based atmosphere. That seems to be the gold standard they're looking for. Water. Water is probably the most common molecule in the universe. We see it all over the place. We see it in the atmospheres of cool stars, which I did my dissertation on in astronomy. We also see it in interstellar medium, the stuff between the stars. We see them in satellites. We see them in planets. We see them in comets. We see it all over the place. But always where we see it, it's either solid or it's a gas. The only place in the universe where we know for sure that liquid water exists is on the Earth. There have been claims that might exist briefly on the Martian surface, that might exist below the surface of some of the satellites of the outer planets, but those are just possibilities. It's not been confirmed and may never be confirmed. But we know we have plenty of liquid water here, and we know that liquid water is essential for life. It's your body is like 75% water, and there's a good reason for that. So water, an essential ingredient for life, liquid water, only exists here as far as we know. And that's amazing for something that's so abundant in the universe.
Yeah. But Danny, that almost takes us back again to the incredible order that exists, not only in just the visible, but even down into the invisible, even mathematics as well, doesn't it?
You know, there are four fundamental physics forces they talk about: the strong, the weak, the electromagnetic, and the gravitational. Except that 35, 40 years ago, they kind of combined the electrical and weak forces. So now we have three. And we've seen this unification of physics before. They want to unify into a single theory. So the belief is that eventually we can wed the strong and the electric and weak forces into one. We call that the grand unified theory, which is GUT for short. And then ultimately gravity, which is the tough one, because it's so much different from the others, weaker than the others. If we can unify that, then we have what's called the theory of everything, TOE. The belief is that there's a simple underlying theory behind everything. And to me, that speaks of design, because we saw all these disparate forces, and there's this belief that there's this unity here, but what are you basing that belief on? Well, some experience you've had, but very few physicists seem to be asking the question, well, why is there this simplicity here? And you've got to think either just that's the way the world is for no apparent reason, or the world is that way for a purpose and design. And to me, that speaks of creation. We also see in particle physics a lot of symmetry going on, and a lot of neat little things. For instance, elementary particles seem to come in groups of six. Why six, you know? And there's some unity inside of all of that, and they've filled in this beautiful basic theory of how all this works, again, tied into this idea of simplicity. So we see this order coming out of all of this. And why is the world so ordered? And it's just taken as a given. That's just the way it is. But, you know, philosophically, why? Theologically, why is it like that? And to me, that just screams of design in the universe. Just like you were talking before about design in biological systems, we're seeing design in the very fundamental physics of the world around us.
And an order that extends down to the particles and extends all the way
smallest things to the biggest things in the universe. It's a wide range, many orders of magnitude, and that's remarkable if you don't believe in a creator.
Yeah, that's true. Danny, when we talk about all of this design, it just makes me think that all of this really was made by God for us.
Sure.
Is that how you see that?
Oh, yeah.
That means we're more significant than what we've heard from other people.
Oh, yeah. You know, back in 1972 or 73, I believe it was, Brandon Carter coined a term called the anthropic principle. This idea that a number of things about the universe that seem to make it ideally suited for our existence. That is, man is here for a purpose and a reason in the cosmos. And Barrow and Tipler wrote a book 30 years ago called The Anthropic Principle. It goes on for 1,000 pages plus, with a whole history, full discussion of all this. And when all is said and done, you know what the conclusion was? The universe just appears designed. So it's a situation where they were confronted with all the evidence they really needed, and then they just walked away from it, arguing instead it was just appearance of design, not real design at all. And again, I keep saying this, but it comes back, it's not a head problem, it's a heart problem. If you do not believe something, truly do not believe it in your innermost being, then you are going to deny that truth and reality given to you. Many times we just think that if we can just convince people, argue persuasively enough, people will accept it. But my experience over the years has been that people don't want to believe what they don't want to believe.
Right.
You know, with creation, evolution, I've seen people confronted with all sorts of evidence against evolution for creation. They admit you make a good case, but when you're done, they simply say, well, I'm going to continue to believe in this. It makes no sense, because you see, it's not a head problem, it's a heart problem.
Right. Well, Danny, all that we have talked about tonight and all that we have seen, the awe associated with not only the visible aspect of the stars, but even the invisible things we've talked about that come together to make us understand and help us realize that God has made all of this, and the evidence just seems to be overwhelming. And yet, at the same time, we have the reality that in the face of that evidence, people still don't see it. That there is a strength associated with a paradigm that will keep people from seeing what we appear to think is plain.
Well said. Amen.
But there are a lot more stars out here. I'm sure you can.
Oh, yeah. You know, we've been out here quite a while.